Hello there, and in the last video we talked about how to construct a confidence interval for the slope of the line of best fit, which in this case we referred to as beta 1. In this video we're going to focus on a confidence interval for the other parameter, beta 0. And here that's going to be estimated by the slope of our line of best fit, which is usually equal to b. So just as we said last time, m is a point estimate for beta 1. Similarly, b is going to be a point estimate for beta 0. So if that is true, then that means we should have some idea of how to construct a confidence interval for it. So our confidence interval for beta 0 under some level of confidence is going to be equal to b minus some marginal error and b plus some marginal error, where the marginal error is going to take some structure. I'm not going to derive where this formula comes from, but in this case this is going to be equal to a t critical value times the square root of SSR divided by m minus 2, and this part is a little bit messy looking, but it's going to be the square root of the reciprocal of the sample size plus the square of the sample mean of x divided by the variance of x times n minus 1. And that gives us the margin of error for a confidence interval for beta 0. And then we can do some hypothesis tests based on that. Alright, so with that being said, let's go to Excel and sort of go through this process. So I'm going to be using the same exact Excel spreadsheet that I was using in the last video, and I'm going to sort of pick up where we left off. So for this, let's see what we need here. So we can calculate our variance of x by either squaring our standard deviation or calculating it directly in Excel. So remember, we can do variance of x of column A. So that's going to be the variance of x. And also we need the mean of x as well. So I'm going to shift some things around. So the mean of x is going to be equal to the average of column A. So now we can construct our margin of error for our confidence interval for m. So our b, or our margin of error for b. So our b error is going to be equal to the t critical value times the square root of our SSR divided by n minus 2, and then times the square root of the reciprocal of our sample size, so 1 over n, plus on the top it's going to be our average of x, the quantity squared, divided by the product of the variance of x times n minus 1. And here it's very easy to make mistakes on your parentheses because there's definitely so many there. Alright, so our confidence interval for b is going to be equal to CIB. So again, we're going to have a lower bound and an upper bound since we're doing a two-sided hypothesis test usually. So we're going to center this around b. So according to this, b is equal to 817.1 according to this line of best fit here. So this is going to be equal to b minus our margin of error for b and b plus our margin of error for b. Oops. This is equal to b plus 485. All right, there we go. All right, so this is our confidence interval for the intercept of the line of best fit. So what does that mean? So we can ask some questions here if we need to. So let us assume that x corresponds to a 0 level of satisfaction. Right, so if you're 0% satisfied with your company, how much are you willing to get paid? Because that's pretty much what this intercept corresponds to, right? So of course we have some confidence interval that is going to be sort of situated around this confidence interval. And according to this, we have 331 and 1302. So this is going to be 331 and 1302. And we were working under a 96% level of confidence. So that means what? So that means we are 96% confident that if you hate or totally hate your job, you will make a weekly salary of between $331, which is not much at all, and $1302, which is a lot. It depends really what your job is, whether that's a lot or not. So does that really make sense? Well, if you really hate your job, usually you're not going to really perform as well as you should if you have, passion for your job or so forth. Usually this is seen in a lot of, artist jobs or, server jobs or cooking jobs or whatever. So of course, maybe that's, contributing to this type of trend that we see here. But that's pretty much how you construct a confidence interval for the intercept of our line of best fit, and pretty much how to interpret it and apply it to standard applications.